This is a GCSE Maths video on solving simultaneous equations graphically. So it says here, simultaneous equations can be solved graphically by drawing each line on the same set of axes. The point of intersection of the two lines gives the only values for x and y which satisfy both equations. So what does that mean? We got to draw this line here. We're going to draw this line here. Straight line graphs. Where they cross each other is the solution. So these are a wee bit funny the way they're set up, so we need to rearrange them. I'm going to rearrange this one up here. Excuse the slight mess. I'm going to take the x over to the other side. So if I add x to both sides, I'm going to get 2y equals x minus 4. Again, that's still no good to us. We like our lines in the form y equals mx plus c. Now you can pick numbers and sub them in, that's okay, but it's nicer just this way, I think. So dividing both sides by 2, then y equals a half x minus 2. Now we can read off the information we need from that. We know m is a half. The gradient of this line here is a half, and the y-intercept is minus 2. This one here is a bit similar. We need to take the x over to the other side. Y equals minus x plus 7. So here our gradient, be careful with this one, that's going to be a minus, gradient's always the thing multiplied by x, so that's going to be minus 1. And then my c is going to be 7. Let's plot this first one. So we always start then with our y-intercept, so it crosses at minus 2. So I go down here to minus 2. Hopefully you can see that. And our gradient's a half. That means every time I go across one, I go up a half. So across one, up a half, and you can see that's actually my easiest point to plot, across 2 and up 1. If you want to think about it rise over run, that'll work as well. I'm going up 1 for every 2 going across, but the gradient always tells you how many you go up for every 1 that you go across. Across 1, up a half, 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 and again, you hopefully see the pattern, and I can start to do my lines from there. The lines should always go all the way through the graph, so I'll extend it on out this way as well. You maybe can't see it, I think you can. If I draw my line in here then as neatly as I can. So the name of that line is of course y equals a half x minus 2, or if you want it, 2y minus x equals minus 4. That's fine. So my next line then, y equals minus x plus 7. I always start then at the 7, so it's going to cross here. And then I have a gradient of minus 1, so every time I go across one, I go down 1. Across 1, down 1, across 1, down 1. This one's nice and straightforward, so there'd be no hassle. And so I can extend my line on out then like this. Goes all the way across and down. The name of that line, as I said, is y equals minus x plus 7. Solution then is where the two lines cross each other. I hope it's reasonably obvious then to people. So it's going to be at the point here. So what's my x coordinate? My x coordinate here is going to be x equals 6. And my y coordinate then is going to be 1. So the solution to those simultaneous equations is x equals 6 and y equals 1.